So, hi all, this is Lakshmi working as assistant professor in the Department of ECE at SNSCT. So, today I'm here to discuss about the lecture series on smart sensors and devices. And the topic which I'm going to discuss here is about the variable capacitive type sensor. So, based on the capacitive effect, the variation in the three parameters of the capacitance can be used in various sensor applications. So let us discuss in detail about this variable capacitive type sensor. So first of all, we must understand the principle behind this capacitive effect. So this works based on the change in capacitance in response to any physical quantity. So for example, displacement, velocity, acceleration, force, pressure, vacuum, fluid level, audio sound field, humidity, and all these parameters, if there is any change in these physical parameters, there will be a change occurring in the capacitance. So this can be measured using the capacitive transducer. So this is mainly based on the equation which is C is equal to epsilon A by D Farad. So Farad is the standard unit of capacitance and epsilon is the permittivity of the dielectric material and D is the distance between the plates and A is the area. So what are the parameters varied in a capacitive effect are? So first is the distance between the two parallel electrodes. So changing the distance between two parallel electrodes, that is D, and changing the dielectric constant permittivity of the dielectric material, and then changing the overlapping area of the plates. So there are three things to be considered here. First is the distance between the two parallel plates, and the second is the dielectric constant permittivity, and then the change in the area of these plates. So these changes can be done by applying force, pressure, displacement, etc. in the capacitance, and that can be calibrated by the help of bridge circuit. First, let us discuss about the capacitive transducer, which is based on change in the area. So we could see that two parallel overlapping parallel plates where one is considered as a fixed plate and the other one is to be the moving plate. So here the capacitance is directly proportional to the overlapping area. So we have already discussed the equation C is equal to epsilon A by D, where the capacitance is directly proportional to the area, the plates. So with this, W is our A can be redefined as LW. So L is the length of the overlapping plates and W is the width. So hence the C is proportional to the length and this is proportional to the length is proportional to the displacement. Hence this capacitance is directly proportional to displacement. So with the help of this concept, it can be used in measurement of displacement. And then the next is the capacitive transducer for angular displacement measurement. So the basic principle of change in area here can be used for rotational measurement. So one is the fixed plate and the other one is movable plate. So previous case we have discussed about the linear displacement, and in this case we are considering the angular displacement. So we are using the rotatory motion here, and this is mainly used for rotational measurement. So here the capacitance will be maximum when two plates are overlap completely, that is for about 180 degrees. And the last one is the transducer, which is using the change in distance between the plates. So the capacitor of the transducer is inversely proportional to the distance between two plates. So for area, it is directly proportional, whereas the distance between the two plates is inversely proportional. So the one plate of the transducer is fixed and the other one is movable. So the displacement which is to be measured links to the movable plate. So here this is fixed plate and this is the moving plate. So the distance between these two is D. The capacitance is inversely proportional. If the distance increases, capacitance decreases. If the distance decreases, the capacitance increases. So advantages of these type of transducers are, so it requires an external force for operation and it is very useful for small systems. It is very sensitive, gives good frequency response and it also has high input impedance, hence they have small loading effect and also requires only small output power for operation. So these are certain advantages of this capacitive transducer. And the applications of this, the uses of capacitive transducer, they're mainly for both linear and angular displacement, then for measurement of force and pressure, and it is used as pressure transducer in some cases where the dielectric constant changes with the pressure, and in the gas sensing where we can measure the humidity. And also this accuracy, it depends upon the variation of the temperature at higher levels. So it is sensitive to temperature. So today's assessment discuss the disadvantages of this capacitive transducer. So the metallic parts of the transducer, it requires insulation, that is to prevent from any other external things. And the frame of the capacitor, it requires earthing to reduce the impact of stray magnetic field. And also the transducer shows nonlinear behaviors because of the edge effect. And the cable connecting across the transducer also causes an error. So what is the main disadvantage here is metallic parts, it requires insulation, and the frame of the capacitor requires earthing, and it shows sometimes it shows nonlinear behavior, and so that should be controlled by using bordering, and the cable connecting across the transducer also will cause error. So these are the disadvantages of capacitive transducer. So thank you.